All right, so we continue. We want to find exact value of some trig expressions, and the question before us is to find the exact value of sine 225 degrees minus cos 300 degrees tan 150 degrees. You know, if you don't want to use calculator to solve questions like this, our duty is to break these numbers down to have some special angles, the least ones like 30, 15, 45, 60 for easy solving. And so our duty first is to convert this sine 225. We have already studied, if you look at what we said, to refresh your mind, upon the Cartesian, we said the quadrant is all students take coffee. Over here, we say all the trig ratios are positive. Over here, we say sine is positive. The remaining are negative. Over here, tan is positive. The remaining is negative. Over here, cos is positive. And the remaining trig ratios are negative. Okay. So having said that, our duty is to now break this sine 225. Okay. I'll be solving some of them, breaking it down here. Then we look at it. So if you look at 225, 225 falls into which quadrant? It falls into the third quadrant. And wait, because from here to here is 180, and here will be 225. So you realize that over here, it is t, which means that sine is negative here. So whichever way we break this 225 to its smallest form, we should know that it's equal to negative something. But what then is it going to be? You can use the reference angle which we studied to break it down. And so the reference angle for the third quadrant is theta minus 180 degrees. And your theta, so 225. So 225 minus 180 degrees gives you 45. So this is going to be the same as sine 45. And sine 45, we know it is square root of 2 over 2. Sine 45, cos 45, they are all root 2 over 2. And tan 45 is 1. These are basic things we should know. Okay. Now, let's break the, so that's for sine 225. Let's break the cos 300 also down. Yeah, once again, cos 300 also happens to fall in the third quadrant. And once again, cos also is negative in the third quadrant, right? Yes, so cos 300, sorry, cos 300 happens to be in the fourth quadrant because there is 180, 270, so it's false here. Now here, cos is positive. And so what you're going to do now is that it's false in the fourth quadrant, which is 360 minus theta. And so you have 360 minus 300, which will give you what? 60 degrees. So it means this is the same as cos 60 degrees. And cos 60 degrees, we know is half. We've studied it already. And we now come to tan 150 degrees. For tan 150 degrees, 150 falls in which quadrant? So this is 90, 150 falls in the second quadrant. The second quadrant, tan is negative. You see that? So it means that my answer should be negative tan something. But now let's see. In the second quadrant, we said the formula is, to break it down, the reference angle is 180 minus theta. So this will be 180 minus 150, the angle, and the answer is 30. So it means it's almost tan 30. And tan 30, we all know, is root 3 over 3. Then there's a negative here. So now we substitute. So tan 45 is sine 225 is minus root 2 minus 2 minus cos 300 is half times tan 150 is equivalent to tan 30, which is root 3 over 3. So we're going to now break this one down. So you have root 2 over 2. Negative times negative gives me positive. 1 times root 3 is root 3. The negative times positive is negative. So I'm going to have 2 times 3, which is 6. So 2 times 3, and negative times negative, we render out this one positive, right? So If you look at it, the LCM is 6, and 2 into 6 is 3. 3 times minus root 2 is minus 3 root 2, plus 6 into 6 is 1. 1 times root 3 is root 3. So it means that when you put this on the calculator, this is the answer you will get. Okay, let's take another question. You have to find the same exact value of this. Second question. Sine 210 minus cos 330 tan 330. How do you solve question like this? Once again, we need to break it down. So all students take coffee. It should always guide you, because it will help you to know the quadrant you are working in. 210. If you look at 210, 210 is in which quadrant? Because this 90, 180, 210 falls here in the third quadrant. In the third quadrant, tan is negative, right? Tan, sine is negative, tan is positive, then sine will be negative here. And 210, the reference angle for 210 will be theta minus 180. So that will be 210 minus 180 degrees, and that will be 30, right? So this is the same as minus sine 30. Sine 210 is the same as minus sine 30. And sine 30, we all know that sine 30 is half. So we're going to get minus half here. So we now start with the cos 330. Cos 330 is in the fourth quadrant. And in the fourth quadrant, cos is positive, so nothing will change. And we also know that the reference for 330 with 360 minus theta. So you have 360 minus, your theta is 330. So you're going to get 30. So it means cos 330 is the same as cos 30. And cos 30 is with 2. So cos 30 is root 3 over 2. Now let's come to tan. So once again, you can see that tan 330 also will be the same as tan 330. So the same 330, 330. So tan 330 will be the same as minus, because over here, tan is negative, so it will be minus tan 30. And tan 30 is the same as with 3 over 3. Tan 30 is the same as with 3 over 3. So tan, this will be minus tan 30, with a minus root 3 over 3. So now substituting back, we have sine 210 is minus 1 over 2 minus cos 330 is the same as root 3 over 2 times tan 330 is minus root 3 over 3. Okay, so we expand. So this is minus 1 over 2. Negative times negative is positive, and with 3 times root 3 is 3. 2 times 3 gives me 6. So minus half plus 3 over 6 is minus 1 over 2. And minus half plus positive half is 0. So that's the answer. So the answer is 0. Okay, let's move on. For this same question, you can be given to solve for sine squared 30 plus cos squared 30. We have already said that sine 30, we all know that sine 30 is half, but there's a square here, so it means half, then you square everything. Because we said that sine squared 30 is the same as sine 30 all squared, okay? So plus What's cos 30? Cos 30 is root 3 over 2. Okay, so you're going to have root 3 over 2 all squared. So this square is affecting everything here. You're going to have 1 over 4. So that this is the same as 3 over 4. So the LCM is the same. The denominator is the same. So we can say this is the same as 4 over 4. Since the denominator is the same, you can add the numerator and say 1 plus 3 is 4. So 4 divided by 4 is 1. So if you remember, there's a rule say cos square theta plus sine square theta is 1. It's an identity. It's whatever square you have. So if I give you square, cos square 60 plus sine square 60, when you finish solving, by all means, the answer will be 1. You take note of that. Okay. So basically, those are some of the things you should know. Very simple to go. Okay, so we continue. We want to still continue to find some exact values of trig functions. Okay, so there's another way of putting it. Find the exact values of the 6 trigonometric function of theta given each point on the terminal side theta in standard position. So when a question like this is given, we need to actually, put it on a Cartesian plane and plot your 3, 4 on it. So we know that 3 is for the x, then 4 is for the y. So this is y, x minus x, and this minus y. So positive 3 and 4. So if this is 3 on my x, 4 on my y, it falls in this quadrant. We are interested in the angle it makes with the positive x-axis, so my theta will be here. So the length of from here to here is 4, which is the same as here, and from here to here is 3, which is for the x. Now, our duty is to find the hypotenuse, which is also as the radius. So the radius is the square root of your x squared plus your y squared, okay? Which is the same as hypotenuse squared equal to adjacent square plus opposite square. Then you make your hypotenuse the subject. So this is what you're going to get. So we're now going to substitute. My x is 3. And my y is 4. So we're going to have 3 squared is 9. 4 squared is 16. This gives you 9 plus 16, 25. So R therefore will be 5. So it means over here is 5. Then you're now going to find the exact value of the remaining of the 6. So the trig ratios we know are sine theta, cos theta, tan theta, and their respective inverses. So the inverse of sine is cosine. And another way you can also even use to detect that is, let me write cosine so that you check something out. If you look at the word, if you look at the word cosec, okay, look at cosec. If you count from here, 1, 2, 3, it falls on s, so it's 1 over sine. So it means the inverse of sine is cosec, so for easy identification. If you look at the inverse of cos, is the inverse of cos is sec. Now let's count and see. 1, 2, 3, it falls on c, so 1 over cos theta. So it means the inverse of cos is sec. If you come to talk about tan, it's cot. If you count 1, 2, 3, it falls on t, so 1 over tan theta for easy identification. So these are the 6 trig ratios. Now, having gotten R to be 5, we now start solving sine. We all know that sine is which is opposite over hypotenuse. So what's my opposite? My opposite is 4. And my hypotenuse is 5. We are through. Let's come to cos. Let's come to cos. Cos is cut, so adjacent over hypotenuse. What's my adjacent? Adjacent is 3. The hypotenuse is 5. Let's go to tan. For tan is 2. So that's opposite over adjacent. So what's your opposite is 4. What's your adjacent? Adjacent is 3. Now what are its respective inverses? The inverse of sine is cosec. So if sine is 4 over 5, cosec will be 5 over 4, the inverse. So the denominator becomes the numerator and the numerator becomes the denominator. The inverse of cos is sec. So sec will become what? 5 on 3. Then the inverse of tan is cot. So cot becomes, if tan is 4 over 3, cot will become what? 3 over 4. But note that when we are dealing with 3 and 4 fell in the first quadrant. And we know that over here is all students take coffee. So the first quadrant, all the 6 trig ratios are positive. That's why all the answers, we are leaving them in positive. If it were to be in the second quadrant, we know only sine and its inverse is positive. The remaining are negative. So questions like tan, we would have negated it, negated even this one and this one. Okay, the cos and the sine, the sec. But because over here sine is positive, okay, so you will not negate sine and its inverse. But this particular question we are dealing with happened to fall in the first quadrant, so all is positive here. So there's no need for us to actually negate any. So take note of that. Okay, let's move on to the second question. For the second question, we have 2 minus 1. So when you draw the Cartesian plane, 2 is on the x-axis and minus 1 is on the y. So you meet over here. Put your theta here. So 2 will be on the x. So right here is 2. The y is 1. So right here. However, we are not putting minus 1 here because the minus will just help you to know the quadrant in which it falls as it stands now. You cannot measure a length to be negative. So now let's find the radius. The radius is the hypotenuse, will be square root of x squared plus y squared. And my x is 2, you square it. My y is minus 1, you square it. So this will give you 4 plus 1. And 4 plus 1 is 5. So you have square root of 5 to be the radius. Now to find the trig ratios, sine is opposite over, so this is 5. Sine is opposite over hypotenuse. So the theta is, the opposite of this theta is 1. So you have 1 over root 5. But we all know that radical cannot be at the denominator. So we multiply by root 5 over root 5. So you're going to get square root of 5 over 5. Don't forget, in this quadrant in which we are working, according to all students take coffee, this quadrant, which is the fourth quadrant, only cos and its inverse is positive. So only cos and sec is positive. The remaining are negative. So it means that over here, our answer must be left in negative because sine is negative in this particular quadrant. Okay, so sine must be negated. I hope it is clear. So let's move on to finding cos. So cos theta, cos is adjacent over hypotenuse. What's the adjacent? Adjacent is 2 over hypotenuse, which is root 5. Once again, the radical is at the denominator, so we need to rationalize. So we're going to multiply it by root 5, root 5. So this will give you 2 root 5 over 5. Then you check, is cos positive here? Of course. So we will not do anything to it. We will not negate it. Then we now come to tan. Tan is opposite over adjacent, which is 2. Then you check what is happening to tan in this quadrant. Tan in this quadrant is negative, so we negate it. Then I believe you can find its corresponding inverses. So if sine is 1 over root 5, then its inverse, which is cosec, will be root 5 over 1, which is root 5. Okay. If cos is 2 over root 5, then its inverse, which is sec, will be root 5 on 2. So once again, in this quadrant, cosec ought to be negative. Take note of that. Then in this quadrant, sec and its cos inverse, they are all positive, so we don't negate this one. Then for tan, the inverse is cot, and that will be 2 on 1, which is the same as 2. So once again, we need to do what? Negate it. Okay, so these are questions like this also goes. I'll leave the third question for you to try on your own. Okay, so welcome back. We're talking about a unit circle now. A unit circle is a circle centered at the origin, okay, whose radius is 1 unit long. The unit circle is useful in evaluating trig functions. So, for example, if I have a Cartesian plane like this, I draw a circle. Over here becomes cos theta. Over here is sine theta. And the radius becomes 1. The terminal becomes xy. So the unit circle cos theta is the cos theta is the horizontal x-axis, and sine theta is the vertical y-axis. Take note of that. Okay, so now we want to just help you see how the unit circle goes. So for the cos is for x, okay. So x, the cos is for x, then the y is for sine. The y-axis is for sine. Okay, take note of that. Because if I have a Cartesian plane, and I say this is x, this is y. If I put theta here, and I say what is cos theta, you will say cos theta is adjacent over the what? Adjacent over the hypotenuse, right? So adjacent is x. Hypotenuse, we know is 1 unit long because x squared plus y squared. Let's go to the radius, which will be 1. So that will be x over 1, which is x. Sine will be what? Y over 1, which is y. Okay, that's right. Then the tan theta will be your y over x. So this is all you should note. Now, let's go to how to do the unit circle. So we draw a big circle. And see whether I can write again. Let's try. So this is 1, 0. Right here is minus 1, 0. Over here is 0, 1. I will be explaining why later. Over here is 0 minus 1. Okay, because we all know that. So the 1 is for x and the y is for 0. Okay. Now we're starting from 1, 2, 3. Okay, so this is 0 degrees, 30 degrees, then the remaining will add 15, 15. So 15 plus 30 is 45. Then this will be 45 plus this is 60. Then this will be 90. Okay. We can find it corresponding in radian. If you convert 30 degrees to radian, is pi on 6. You convert 45 is pi on 3. If you convert 60 is pi on 3. Yeah, I think if you convert 45 rather is a minute. It's pi on 4 rather, sorry, pi on 4. Then this one pi on 3. Okay. Now let's see what will it be its corresponding. Listen. So you see we said x. This gives you x and y, as you can see here. X, so what will be cos 30? So x is for cos. So what will be cos 30? So what is cos 30 here? Cos 30, we all know we said it is root 3 on 2. And sine 30. Okay. So cos 30, then we find sine 30. Sine 30 is half. What will be cos 45 is root 2 on 2. What is sine 45? Root 2 on 2. What is cos 60? Cos 60 is 1 on 2. And what is sine 60? Sine 60 is root 3 on 2. So now if you come here, what is cos 90? Cos 90 is 0. So sometimes you say people say cos 90, you've done cos 90 work, which means you've done 0 work. Then sine 90 is 1. This same thing can be replicated in different places. So right now, this line over here can be replicated over here. So you can almost tell me what this one will be. Because over here in this quadrant, x is negative and y is positive. So if you translate this one here, it will be minus root 3 on 2 against 1 on 2. This particular line, this line gave us this. So this line will give us this. And this line will give us this. And we said from 90, you add 30 to it, so making 120. 8 radian form is 2 pi on 3. As time goes on, the remaining, I'll leave it for you. So this particular line translated to this one translated to this, and this one translated to this. So this one, it means that we're getting something like minus half, because this is the one that translated to this. Your x should be negative, then your y is still positive. So this one translated to this. So this one translated to this. So this one will be what? Minus root 2 on 2 against root 2 on 2. The same thing applies to this quadrant also. In this quadrant, your x is positive, then your y is negative. So this same thing over here is what translated here. Okay, so right here we said that from 90 you add 120. From 120 you add 15, 15. So this will be 135. You can convert it to radian. This is 150. You can convert it to radian and see what you get. And this will be 180, which is the same as pi. The last one, 30, first 30, we're in between 15, 15. So, and not forget over here in this quadrant, we said that your y is negative, but your s is positive. So if this is what it's translating here, then this will be root 3 on 2 against minus 1 on 2. This particular one is what is translating here. So I'm going to get root 2 on 2 against minus root 2 on 2. This one is what is translating here. So I can write this as 1 on 2 against minus root 3 on 2. And from 180, you add 30 to 8. And if you add 30 to 180, you're supposed to get 210. Then 210, you add 15, you get 225. 225, when you add 15, you get to 240. And 240, when you add 30, you get to 270. And don't forget, if you want to check it out, cos 270, you get 0. And sine 270, you get minus 1. You can check it out. Okay, you can check it out on the calculator. So that cos 270 will give you 0. So the same thing applies over here. Over here, this same one is translating here, translating here, translating here in that order. So from 270, if you add 30, you come to 300. And the 300, this was translated here. So what are you supposed to get? This one translated. I guess you can now see what you're supposed to get from this. So this one is translating. You're going to get everything over here. You see that x is positive and y is negative. Oh, so sorry. Over here, rather, x is negative, y is negative. So sorry. All here is supposed to be negated. But over here, rather, y is negative, then x is positive. So we will get root 3 on 2 here against negative half. This one translated here. This one translated here, we will get root 3 on 2. Sorry, root 2 on 2. Root 3 on 2 against 1 on 2. So against minus 1 on 2. I hope I'm not making a mistake. Okay, yeah. So root 2 on 2 against minus root 2 on 2. Then the last one will be 1 on 2 against minus root 3 on 2. So basically, this is the trig ratio, and we say that this unit circle is useful in evaluating trig functions. So if you look at some of the questions that we solved, if I give you sine 225, okay, where I did using the reference angle and I said 225 for cos 225. If I give you cos 225, okay, we said I need to break it down to simplest way. And with this unit circle, you can know that cos 225 is the same as what? This for the cos, it's for the x. So minus root 2 over 2 straight away. But if you don't want it like that, means you need to use the reference angle, which is theta minus 180, which was 225 minus 180, and we got 45. So we say cos 45. It falls in this quadrant, which was negative. And cos minus cos 45 gives you minus root 2 over 2. All right, so basically that is it for unit circle. All right, so we move on. When a question like this is given in trigonometry, here's what you need to do. First of all, you see question like given that tan y is 5 over 12, or if tan y is, you need to first of all draw when you see questions like this. So when I put my y here, we know tan. Tan is opposite over adjacent. So what's the 5 is the opposite, then the 12 is the adjacent. Okay, take note of that. So the 5 is the opposite, so that will be here. And this is the adjacent. So 12 will be here. So I need to find my hypotenuse. So we say hypotenuse, we can say A. So A squared equal to 12 squared plus 5 squared. So this gives you 144 plus 25. And that will give you 169 equal to A squared. So A, therefore, the square root of 169, which is what? 13. So my A is 13. Then now, the question says we should find sin y. So let's reduce sin y first. So sin y, sin is opposite, which is 12, over hypotenuse, which is 13. Cos also is in the question, so let's find cos. Cos y. Cos is adjacent, which is 5 over 13. Then now we substitute and solve. So sin y is 12 on 13 all over sin square y, which is 12 on 13, all squared, as we said, plus what's cos y, 5 on 13. Then now we need to simplify this. So this will be 12 on 13 all over 144 over 169 plus 5 on 13. So the numerator is 12 on 13. But let's simplify the denominator. Simplifying the denominator, the LCM is 169. LCM of 169 and 13 is 169. 169 to 169 is 1. 1 times 44 is 144. Plus 13 to 169 is 13. And 13 times 5 will give you 65. So we have 12 over 13 all over 144 plus 65 will give you 209. Okay, over 169. So this is the same as 12 on 13 divided by 209 on 169, which is the same as 12 on 13 times 169 over 209. Okay. So 13 will go into 169 13 times, and 13 times 12 is 156 over 209. Okay, so let's quickly go over again and see whether we are correct. So this will give us this give us this. Okay. So a minute, let's check it out. Okay. Okay, so we move on. Okay, out of if we have given that cos x is 3 on 5 and 270 degrees, that's equal to x, that's equal to 360. This simply means it's in the fourth quadrant. Find the value of 2 minus sine square x over 1 minus sine x. How do you solve question like this? So once again, the first thing you need to do is to draw the right angle triangle. When you put your x here, cos is adjacent hypotenuse. So this is 3 and hypotenuse will be 5. So your duty is to go and find the opposite. So once again, hypotenuse squared using Pythagoras theorem is equal to 3 squared plus a squared. So this will be 25 equal to 9 plus a squared. This will be 25 minus 9 equal to a squared, which is 16 equal to a squared. And your a will be equal to 4. So it means my a here is 4. So I can deduce sine easily and say sine x is which is opposite over hypotenuse. Then you need to check on the quadrant because they said 270 to 360. So this all students take coffee. So this is in this quadrant. What is happening to cos in this quadrant is positive, but what is happening to sine in this quadrant is what? Negative. So it means my answer is supposed to be minus 4 over 5. Then we now substitute. So we have 2 minus, wherever I'll see sine square s, I'll put minus 4 on 5. I'm squaring it because of this square. Then all over 1 minus, my sine already is minus 4 on 5. I hope you're getting it. So this gives you 2 minus 4 squared gives you 16. And 5 squared gives you 25. Yeah. All over. This gives you 1 plus negative times negative is positive 4 on 5. So let's still continue. This will be 2 minus 16 on 25 divided by this 5 times 1. 5 times 1 is 5 plus 4, 9 over 5. So let's try and see how we can break this one down. So you have 2, this is 2 over 1. Okay. Minus 16 on 25. Or better still, let's do it like this rather. So you have 2 minus this is 16 divided by 25 times this will become 5 over 9. So 5 here 1, 5 here 5. And the same as 2 minus 16 on 45. Over 5 times 9 is 45. This over 1. The LCM is 45. 1 into 45, 45, 45 times 2, 19. Minus 45 into 45, 1 times 16 is 16. And 90 minus 16 gives us 74 over 45. And that ends it. So you take note of that. Okay.